Find the integral of the function sine square of 2x plus 5. Let's write integral of sine square of 2x plus 5 dx. So let us put or substitute 2x plus 5 is equal to t. So differentiating with respect to 2x, we have 2 into dx is equal to dt, or dx is equal to 1 by 2 dt. So the integral can be taken as sine square t into dx is nothing but 1 by 2 dt. So we can write it as integral, and we know that the property cos 2a is equal to 1 minus 2 sine square a, or we can write 2 sine square a is equal to 1 minus cos 2a, or we can write sine square a is equal to 1 minus cos 2a upon 2. So here sine square t we can write it as 1 by 2 is here, 1 by 2 times of sine square t is 1 minus cos 2t divided by 2 dt, or we can write this as 1 by 4 times of integral of 1 minus cos 2t dt, which is equal to 1 by 4 times integration of 1 dt minus integral of cos 2t dt. So 1 by 4 times of integration of 1 dt is t minus integration of cos is sine. So we can write sine 2t divided by 2 plus integral constant c. So we can write 1 by 4 times t minus 1 by 8 times sine 2t plus integral constant c. Substituting back t is equal to 2x plus 5, we can write 2x plus 5 upon 4 minus 1 by 8 times of sine 2 times of 2x plus 5 plus integral constant, or we can also write it as x by 2 plus 2x upon 4 is x by 2 plus 5 by 4 can be taken as constant, so minus here minus 1 upon 8 times sine of 4x plus 10 plus 5 by 4. Here you can say this 5 by 4 plus constant, we can take another constant as integral constant plus c. So x upon 2 minus 1 upon 8 times of sine of 4x plus 10 plus c is the answer. Find the integrals of the function sine 3x into cos 4x. We can write integral sine 3x into cos 4x dx. So we can write, we know that 2 sine a cos b is equal to sine a plus b plus sine a minus b. So sine a cos b can be taken as 1 upon 2 times of sine of a plus b plus sine of a minus b. So here we can write integral 1 upon 2 times of sine of 3x plus 4x plus sine of 3x minus 4x dx. So which is equal to, or 1 upon 2 can take outside, integral of sine 7x plus sine of negative x dx, or 1 by 2 times of integral of sine 7x dx and sine of negative x is minus sine x, so we can write minus integral of sine x dx, which is equal to 1 upon 2 times of integration of sine 7x is minus cos of 7x divided by coefficient of x is 7, so divide with 7, and again here minus 1 by 2 times integration of sin x will be again minus, so we can write minus cos x upon coefficient of x is 1 plus integral constant c, so we can write minus 1 by 14 cos 7x minus of minus, so plus 1 by 2 times of cos x plus integral constant c is the answer. Find the integral of the function cos 2x, cos 4x, cos 6x dx. So we can write integral of cos 2x into cos 4x into cos 6x dx. And let's use the property 2 cos a cos b is equal to cos a plus b plus cos of a minus b. So that cos a cos b can be taken as 1 by 2 times of cos a plus b plus cos of a minus b. So we can write here integral cos 2x into 1 by 2 times of cos of a plus b, that is 4x plus 6x plus cos of 4x minus 6x, the whole dx, which is equal to integral cos 2x 1 by 2 times of cos 10x plus cos of 4x minus 6x is minus 2x, whole dx, which is integral cos 2x 1 by 2 times of cos 10x cos of negative theta is plus cos theta, so plus cos 2x whole dx. So we can write here 1 by 2 times integral cos 2x into cos 10x dx plus 1 by 2 times of integral cos square 2x dx. So again you can apply here 1 by 2 times of cos a cos b formula. So here this is a and this is b. So we can apply the formula here. So I can write 1 by 2 times of again cos 2x plus 10x is 12x plus again cos 2x minus 10x is minus 8x dx plus again here 1 by 2 times of, and we know the property cos square theta is equal to 1 plus cos 2 theta upon 2. So we can apply here integral of 1 plus cos 2 into 2x, that is 4x divided by 2 whole dx. On simplifying, we'll get 1 by 2 into 1 by 2. This is 1 by 4 times of is integration. So integral of cos 12x we can write sine 12x upon 12, and cos of negative 8x is cos 8x. So integration of cos 8x is sine 8x upon 8, and again plus here 1 by 2 into 1 by 2 1 by 4 times of, so integration of 1 dx is x, integration of sine cos 4x is sine 4x upon 4 plus integral constant c, or we can take 1 by 4 whole common, sine 12x upon 12 plus sine 8x upon 8 plus x by 4, or 4 is taken common, only plus x plus again sine 4x upon 4 plus integral constant c is the answer. Find the integral of the function sine power 3 of 2x plus 1 dx. So let us substitute or put 2x plus 1 is equal to t. On differentiating with respect to 2x, we have 2 dx is equal to dt, or dx is equal to 1 upon 2 times of dt. So here we can write integral sine power 3 into t dx is 1 by 2 dt, that is 1 by 2 times integral sine power 3 dt. And we know that sine 3a formula 3 sine a minus 4 sine cube a. So from here we can write sine cube a is equal to 3 sine a minus sine 3a upon 4. So let us substitute here 1 by 2 times of again 1 by 4 integral of 3 sine a 3 sine t minus sine 3t dt. Let's integrate here 1 by 8 times of 3 times integration of sine is minus cos t, and again here minus integration of sine is minus cos 3t. So minus of minus cos 3t upon the coefficient of t is 3 plus integral constant c. So here we can write which is equal to minus 3 upon 8 cos t, and here minus of minus plus 1 upon 3 times of or 1 upon 24 times cos 3t plus c. And also we can also write this as by using cos 3a formula. We know that cos 3a is equal to 4 cos cube a minus 3 cos a. Let us substitute here in place of cos 3t, let us substitute it. So we can write here minus 3 by 8 cos t plus 1 by 24 times cos 3t, we can write 4 cos cube t minus 3 cos t plus integral constant, or we can write minus 3 by 8 cos t plus 4 upon 24 is 1 by 6 times of cos power 3 t minus 3 upon 24 is 1 by 8 cos t plus c, or minus 3 by 8 minus 1 by 8 minus 4 by 8, that is minus 1 by 2, or 1 by 6 cos power 3 t minus 1 by 2 cos t plus c. Let us substitute back t is equal to 2x plus 1, so we can give the answer as 1 upon 6 cos power 3 of 2x plus 1 minus 1 upon 2 cos of 2x plus 1 cos cube of 1 by 2 cos of 2x plus 1 plus c is the answer. Okay. Find the integral of the function sin power 3x into cos power 3x dx. So this can be written as integral sin square x into cos power 3x into sin x dx, or sin square we can write 1 minus cos square x into cos power 3 x into sin x dx. So let us substitute or put cos x is equal to t, which implies negative sin x dx is equal to dt on differentiating. So we can write or sin x dx is equal to minus dt. So our integral we can write 1 minus t square into t power 3 sin x dx is negative dt, or we can write integral t square minus 1 of t power 3 dt, that is integral of t power 5 minus t power 3 dt. So integration of t power 5 dt minus integral of t power 3 dt. So integration of t power 5 is t power 6 upon 6 minus integration of t power 3 is t power 4 upon 4 plus c. So substituting back t is equal to cos x. So we can write 1 upon 6 cos power 6x minus 1 upon 4 cos power 4x plus integral constant c is the answer. Find the integral of the function sin x into sin 2x into sin 3x dx. Let us write it as sin x into sin 2x into sin 3x dx, and we know that 2 sin a sin b, which is equal to cos a minus b minus cos of a plus b, or sin a sin b we can write 1 by 2 times of sin a sin b, we can write 1 by 2 times of cos of a minus b minus 1 by 2 times of cos of a plus b. So let us substitute here. We can write sin x into sin 2x sin 3x, we can write 1 by 2 cos of 2x minus 3x minus 1 by 2 cos of 2x plus 3x to dx. On simplifying, sin x, or 1 by 2 is common, I can take 1 by 2 outside. Sin x into cos of 2x minus 3x is cos of negative x minus cos of 5x dx, or we can write 1 by 2 integral sin x into cos of negative x, we can write it as cos x minus integral sin x into cos of 5x dx, or 1 by 2 integral. So here we can multiply and divide with 2. So 1 by 2 times of 2 sin x cos x dx, and here I can write 1 by 2 times integral and again multiply and divide with 2, 2 sin x into cos 5x dx, and we know the property 2 sin a cos b is equal to sin a plus b plus sin of a minus b. So I can write here, so 1 by 4 times of integration, this is 2 sin x cos x is sin 2x, we can write integral of sin 2x dx, and here we can write 1 by 4 times of integral of 2 sin x cos 5x is sin of x plus 5x is 6x plus sin of x minus 5x is minus 4x dx. So further simplifying, we can write 1 upon 4 integration of sin is minus cos 2x upon 2 minus 1 by 4 times integration of sin is negative cos 6x upon 6, and here minus of minus will become plus, or minus, let me write minus integration of sin of x is minus cos x, so minus of minus plus cos 4x upon 4 plus constant, or we can write minus 1 by 8 cos 2x, and here minus of minus plus 1 by 24 times of cos 6x, and again here minus 1 by 16 times of cos 4x plus integral constant c, or we can take 1 by 4 common here, So we can write 1 upon 4 taken common, and we can write here 1 by 6 times of cos 6x minus 1 by 4 times of cos 4x minus 1 by 2 times of cos 2x plus c is the answer. Find the integral of the function sine of 4x into sine 8x dx. So we know that sine a sine b is equal to 1 by 2 times of cos a minus b minus 1 by 2 times of cos a plus b. So we can write here integral 1 by 2 cos of 4x minus 8x minus 1 by 2 cos of 4x plus 8x dx. Or we can take 1 by 2 common. Integral of cos 4x minus 8x is minus 4x minus 1 by 2 cos of 4x plus 8x is 12x dx. Or we can write 1 by 2 times. So here we can write 1 by 2 times of cos of integration of cos 4x dx minus integration of cos 12x dx. That is 1 by 2 times integration of cos is sine 4x divided by coefficient of x is 4 minus again sine 12x divided with 12 plus constant c. Or we can give the answer as 1 by 2 into 1 by 4 sine 4x minus 1 by 12 times of sine 12x plus integral constant c is the answer. Find the integral of the function 1 minus cos x upon 1 plus cos x. So we can write integral 1 minus cos x upon 1 plus cos x dx. And we know that cos x is equal to 2 cos square x by 2 minus 1, or we can write 1 plus cos x is equal to 2 cos square x by 2. Similarly, 1 minus cos x is equal to 2 sine square x by 2. So let us substitute here integral of 2 sine square x by 2 upon 2 cos square x by 2 dx, or this can be written integration of tan square x by 2 dx. So let us put x by 2 is equal to t, which implies 1 upon 2 dx is equal to dt. So dx is equal to 2 times of dt. So we can write integral tan square t into dx is 2 times of dt. So 2 times integration tan square t dt. 2 times we can write integral of secant square minus tan square t is equal to 1. So we can write secant square t minus 1 of dt, which is equal to 2 times integration of secant square t dt minus integration of 1 dt. In 2 times integration of secant square is tan t minus integration of 1 is t plus c. Let us substitute it back. T is equal to x by 2. So we can write 2 tan x by 2 minus x by 2 plus c, or this can also be simplified as 2 tan x by 2 minus 2 into x by 2 is x plus c is the answer. Find the integral of the function cos x upon 1 plus cos x. So we can write integral cos x upon 1 plus cos x dx. So here in this case, let us add and subtract 1 in the numerator. 1 plus cos x minus 1 upon 1 plus cos x dx. So we can separate them. 1 plus cos x upon 1 plus cos x minus 1 upon 1 plus cos x dx. Or we can write here integration of 1 plus cos x upon 1 plus cos x will be 1. So 1 minus 1 upon 1 plus cos x dx. So we can write here integration of 1 dx minus integration of 1 upon 1 plus cos x is nothing but 2 cos square x by 2 dx. Or you can write integration of 1 dx minus 1 upon 2 integration of secant square x by 2 dx. So the first integral we can write integration of 1 dx is x minus 1 upon 2 times. In the later integral we can use put x by 2 is equal to t, so that dx is equal to 2 dt. So 1 by 2 into integral of secant square t into 2 dt. So the 2 and 2 get cancelled. So we can write here x minus integration of secant square t. Secant square t we can write it as, we know that secant square theta minus tan square theta is equal to 1. So secant square theta is equal to 1 plus tan square t we can write. Or normally we can integrate it. Let us use integration directly. So we know the integration of secant square is tan t. So we can write here tan t plus c. Since t is equal to x by 2, we can write x minus tan x by 2 plus c. So x minus tan of x by 2 plus c is the answer. Find the integral of the function sine power 4 x dx. We can write this as integral of sine square x whole square dx, which is equal to integral of, we know that sine square x is equal to 1 minus cos 2x upon 2. So we can write here 1 minus cos 2x upon 2 whole square dx. That is 1 upon 4 times integral 1 minus cos 2x whole square, that is 1 plus cos square 2x minus 2 times of cos 2x dx. And also we can write cos square x is equal to 1 plus cos 2x upon 2. So by using this we can write cos square 2x is equal to 1 plus cos 4x upon 2. So here I can write 1 upon 4 times integral 1 plus 1 plus cos 4x upon 2 minus 2 times of cos 2x the whole dx. So we can write 1 by 4 times of integration of 1 plus 1 by 2 plus 1 by 2 cos 4x minus 2 cos 2x dx. Let's integrate 1 upon 4 times of integration of 1 is x plus x by 2 min plus 1 by 2 integration of cos is sin 4x upon 4 minus 2 sin 2x upon 2 plus integral constant c. So 1 by 4 times of 3 by 2x plus 1 by 8 sin 4x minus sin 2x plus c is the answer. Find the integral of the function cos power 4 2x dx. So this we can write cos square 2x whole square, and we know that cos square theta is equal to 1 plus cos 2 theta upon 2. So here cos square 2 theta we can write 1 plus cos 4 theta upon 2. So here we can write here 1 plus cos 4x upon 2 whole square dx. On expanding we can write 1 by 4 times 1 plus cos square 4x plus 2 times of cos 4x the whole dx. On simplifying you can write 1 by 4 integration of 1, and again cos square 4x we can write 1 plus cos 2 times 4, that is 8x, divided by 2 plus 2 cos 4x the whole dx, which is equal to 1 by 4 times integration of 1 plus 1 by 2 plus 1 by 2 cos 8x plus 2 times cos 4x the whole dx. Now in integrating we'll get 1 by 4 integration of 1 dx is x, integration of 1 by 2 is x by 2, and integration of cos x is sin x. So 1 by 2 into sin 8x divided by 8, and 2 times of integration of cos is sin 4x upon 4 plus integral constant c. So we can add 1 by 4 times of 3 by 2 x plus 1 by 16 times of sin 8x plus 1 by 2 times of sin 4x plus c. Or we can also write 3 by 8x plus 1 by 64 times of sin 8x plus 1 by 8 times of sin 4x plus c is the answer. Okay. Find the integral of the function sin square x upon 1 plus cos x dx. Let us recall the formulas. Sin theta is equal to 2 sin theta by 2 into cos theta by 2, and 1 plus cos theta is equal to 2 cos square theta by 2. So let us substitute here. Sin square x we can write 2 sin x by 2 into cos x by 2 whole square divided by 2 cos square x by 2 into dx is equal to 4 times of sin square x by 2 into cos square x by 2 divided by 2 cos square x by 2 dx. So we may cancel here 2 times, and cos square x by 2 cos square x by 2, and next again we can also write 1 minus cos theta is equal to 2 sin square theta by 2. So integration of 2 sin square x by 2 dx, we can write it as 1 minus cos x integral dx. So integration of 1 dx is x, and integration of cos x is sin x plus constant c. So x minus sin x up plus c is the answer. Find the integral of the function cos 2x minus cos 2 alpha divided by cos x minus cos alpha dx. And we know that cos 2 theta is equal to 2 cos square theta minus 1. So let us substitute here. Cos 2 alpha is 2 cos square x minus 1 minus cos 2 alpha, we can write 2 cos square alpha minus 1 upon cos x minus cos alpha dx. So here we can write 2 cos square alpha minus 1 minus 2 cos square alpha, so this is x and this is plus 1, divided by cos x minus cos alpha dx. So here minus 1 and plus 1 gets cancelled, and if it's simplified, 2 taken common, cos square x minus cos square alpha divided by cos x minus cos alpha dx. So 2 times integral, we can write the numerator as cos x plus cos alpha into cos x minus cos alpha divided by cos x minus cos alpha, so that we can cancel the numerator and denominator into dx. So which is equal to 2 times integral cos x plus cos alpha dx. So 2 times integration of cos x is sin x, and integration of cos alpha is a constant, and integration of 1 dx is x. So here we can write plus c. So 2 times of sin x plus x cos alpha plus c is the answer. Find the integral of the function cos x minus sin x upon 1 plus sin 2x dx. We can also write the numerator cos x minus sin x, and denominator 1 we can write it as sin square x plus cos square x plus sin 2x we can write 2 sin x cos x. So that cos x minus sin x upon the denominator we can write sin x plus cos x the whole square. Let us substitute or put sin x plus cos x is equal to t, so that the differentiating with respect to x, we have cos x minus sin x of dx is equal to dt. So our integral we can write it as cos x minus sin x dx is dt, and 1 by t square. So 1 upon t square into dt. So 1 upon t square integration, that is t to the power of minus 2 dt, that is t to the power of minus 2 plus 1 upon minus 2 plus 1 plus c, that is minus 1 by t plus c. Substituting back, t is equal to sin x plus cos x. So minus 1 upon sin x plus cos x plus c is the answer. Find the integral of the function tan power 3 2x into secant 2x dx. We can write integral tan power 3 as tan square 2x into tan 2x into secant 2x dx, or tan square 2x we can write, since we know that secant square theta minus tan square theta is equal to 1. So tan square theta is equal to secant square 2x minus 1 into tan 2x into secant 2x dx. Let us substitute 2x is equal to t, so which implies 2 dx is equal to dt, that is dx is equal to 1 by 2 dt. So integral secant square t minus 1 into tan t into secant t dx is 1 by 2 dt. So now let us substitute again put secant t is equal to some u. So we'll get integration. Secant differentiation is secant t into tan t dt is equal to du. So we can write u square minus 1 into secant t tan t dt is equal to du, you can write, which is equal to 1 by 2. Integration of u square is u to the power of 3 by 3 minus integration of 1 is u plus constant. Now let us substitute u value as secant t. So secant cube t by 3 minus secant t plus c, or we can add 1 by 6 secant power 3 t minus 1 by 2 secant t plus c is the answer. Now replacing back t is equal to 2x. So we can write 1 by 6 secant power 3 2x minus 1 by 2 secant 2x plus c is the answer. Find the integral of the function tan power 4x. Integral tan power 4x dx. So we can write integral tan square x into tan square x, and we know that secant square theta minus tan square theta is equal to 1, which implies tan square theta is equal to secant square theta minus 1. So let us write one of the tan square x as secant square x minus 1 into tan square x dx. Further simplifying, secant square x into tan square x minus tan square x dx. So we can write integral secant square x into tan square x dx minus integral tan square x dx. And in the first integral, put tan x is equal to t, so that we have, on differentiating, secant square x dx is equal to dt. So secant square x dx will become dt and tan x is equal to t. So our first integral can be taken as integral of t square dt minus, and integration of tan square x we can write it as second integral. Second integral we can write again secant square x minus 1 by using the property dx. So here we can write t power 3 by 3 plus some constant minus here integration of secant square x tan x, and integration of minus 1 x dx is minus, so minus of minus plus x plus some constant. So let us substitute back t is equal to tan x here. So we can write tan cube x upon 3 minus tan x plus c is the answer. Okay. Find the integral of the function sin power 3x plus cos power 3x upon sin square x into cos square x. We can write integral of sin power 3x plus cos power 3x upon sin square x into cos square x dx. Further simplifying, you can write sin power 3x upon sin square x into cos square x dx plus again integral cos power 3x upon sin square x into cos square x dx. So here sin square and sin power 3 1 will be remain, and here cos square and cos power 3 1 will be remain. So we can write here 1 of sin x upon cos square x dx, and here cos x upon sin square x dx, which we can write sin x upon cos x tan x into secant x dx, and here cot x into 1 upon sin is cosecant x dx. And we know that integral of secant x tan x is secant x, and integration of cosecant x cot x is minus cosecant x plus integral constant c is the answer. Find the integral of the function cos 2x plus 2 sin square x upon cos square x dx. So we can write cos 2x as 2 cos square x minus 1 plus 2 sin square x divided by cos square x dx, or we can write 2 times of sin square x plus cos square x minus 1 upon cos square x dx, integral 2 times of sin square theta plus cos square theta is 1, so 2 into 1 minus 1 upon cos square x dx. This we can write it as integral of 2 1s are 2 minus 1 is 1 upon cos square x dx, that is integration of secant square x dx. We know the differentiation of tan x is secant square, so integral of secant square is tan x. So you can write tan x plus c, which is the answer. Find the integral of the function 1 upon sin x into cos power 3 x dx. So here we can write it as 1 upon sin x into cos power 3x. So let us multiply and divide with cos x here, so that we can write 1 upon tan x into cos power 4x dx, which can also be written secant power 4x dx upon tan x. And the numerator secant power 4 we can write secant square x into secant square x upon tan x, and one of the secant square we can write 1 plus tan square x divided by tan x into secant square x dx. And we know that the differentiation of tan is secant square, so let us substitute or put tan x is equal to t. So on differentiating we have secant square x dx is equal to dt, so that we can write here integral 1 plus t square upon t into dt, or we can write integration of 1 upon t dt plus integration of t square upon t is t dt. Integration of 1 upon t is log mod t plus integration of t is t square by 2 plus constant. Let us substitute it back, t is equal to tan x. So we can write log mod of tan x plus tan square x upon 2 plus c is the answer. Find the integral of the function cos 2x upon cos x plus sin x whole square dx. So we can write integral cos 2x as cos square x minus sin square x upon cos x plus sin x whole square dx. Cos square x minus sin square x we can write cos x plus sin x into cos x minus sin x upon cos x plus sin x whole square. So we can cancel here cos x plus sin x one time, and so put cos x plus sin x is equal to t. So differentiating with respect to 2x, we have minus sin x plus cos x dx is equal to dt. So here we can write cos x minus sin x dx is equal to cos x minus sin x dx will become dt. So here 1 upon t dt, that is log mod t plus c. Substitute back t is equal to mod of cos x plus sin x plus c is the answer. Find the integral of the function sin inverse of cos x dx, and we can write cos x is equal to sin pi by 2 minus x. So we can write here integral sin inverse of sin pi by 2 minus x dx, and we know that sin inverse of sin theta is equal to theta. So here sin inverse of sin, anyhow it is pi by 2 minus x, so we can say pi by 2 integral minus x dx. So we can write integral pi by 2 x minus integration of x is x square by 2 plus c. So pi by 2 x minus x square by 2 plus c is the answer. Find the integral of the function 1 upon cos of x minus a into cos of x minus b dx. So here let us multiply and divide with sin of a minus b divided by sin of a minus b, and we can write here a minus b is equal to a minus x, or we can also write x minus a or x minus b minus x plus a, that is x minus b minus of x minus a. So here 1 upon sin of a minus b, which is constant, I can take outside, integral of sin of a minus b. The sin of a minus b I can write it as sin x minus b minus of x minus a divided by cos of x minus a into cos of x minus b dx. And also we know that sin a minus b is equal to sin a cos b minus cos a sin b. So here we can write 1 upon sin of a minus b integral of sin of x minus b into cos of x minus a minus cos of x minus b into sin of x minus a, the whole divided by cos of x minus a into cos of x minus b. So let us separate them. So you can write 1 upon sin of a minus b into integral of sin of x minus b into cos of x minus a, whole divided by cos of x minus a into cos of x minus b minus cos of x minus b into sin of x minus a divided by cos of x minus a into cos of x minus b, the whole dx. So 1 upon sin of a minus b into integral of, we may cancel here, cos of x minus a, cos of x minus a. So you'll be getting integral of sin by cos is tan of x minus b minus, and here cos of x minus b, cos of x minus b gets cancelled, and here you're getting tan of x minus a. And we know that integration of tan x is log secant x. So here we can write 1 upon sin of a minus b into log mod of secant of x minus b minus log secant of x minus a. So further simplifying, you can get 1 upon sine of a minus b into log of log a minus log b is log a by b. So we can write log secant of x minus b divided by secant of x minus a plus integral constant c, or we can write 1 upon sine of a minus b into log, here 1 upon secant we can write cos of x minus a divided by cos of x minus b plus c. So we can conclude the answer 1 upon sine of a minus b into log cos of x minus a upon cos of x minus b plus c will be the answer. Okay. Integral sine square x minus cos square x upon sine square x into cos square x dx. So we can simplify as sine square x upon sine square x into cos square x minus cos square x upon sine square x into cos square x dx. So we can write here 1 upon cos square x minus 1 upon sine square x dx, which is equal to integral secant square x minus cosecant square x dx. Integration of secant square x we know tan x. Let us write separately secant square x dx minus integration of cosecant square x dx. Integration of secant square x is tan x and integration of cosecant square is minus cot x. So minus of minus cot x plus c, that is tan x plus cot x plus c is the answer. Integral e power x into 1 plus x upon cos square into x into e power x dx. So let us substitute here. Put x e power x is equal to t, and differentiating with respect to x, we have by using UV rule x into differentiation of e power x is e power x plus e power x into differentiation of x is 1. The whole dx is equal to dt, or we can also write e power x of x plus 1 dx is equal to dt. So we got e power x into 1 plus x dx is dt. So we can write the integral dt upon 1 by cos square t into dt, that is integral of secant square t dt. Integration of secant square is tan t. So tan t plus c, substituting back t is equal to x e power x. So tan of x e power x plus c is the answer, which is option B.